So Mason, thank you so much for joining us today. Let's begin with some of the basics. Tell us a little bit about yourself and your role at Nthought.
Well, I mean, my background is in geology originally, and I spent most of my career on the operator side, working for various companies, most recently Anadarko Petroleum. And I moved to Nthought about a year ago, where I'm the vice president of energy solutions. And we focus on building software and hardware solutions for the energy industry, and specifically in my group, mainly for oil and gas. Now, Nthought as a company focuses on digital transformation, applied digital innovation. So building solutions mainly around software for how companies can get better at solving particular tasks faster with modern technology, and really rethinking a lot of workflows using modern technology stacks to accomplish the workflows with less work, higher efficiency, and better quality of results. And that's really what Nthought is about.
So on the topic of technology at large, topics like AI, machine learning, get a lot of buzz these days, right? Those are top of mind for a lot of folks. These are areas that your company has been very active in. Tell us a little bit about AI, machine learning, and how you're utilizing those technologies.
So AI and machine learning have been changing a lot in the last few years. The evolution of the technologies behind them has been really rapid. And really what we're seeing lately is kind of a commoditization of the technological background to AI and machine learning. So, for example, machine learning models are often coming off the shelf, and you can put different networks together to build models to solve different problems. In addition to that, you have all these databases that you can access. So, for example, ImageNet, where you have pictures of dogs and cats and roads and books, text, all these things that you can leverage in your AI and machine learning solutions. All of that is essentially a commodity that you can pull together and build bespoke solutions. So that's really changed in the last few years. That has sort of lowered the bar for entry into the proof of concept space related to AI and machine learning. Now, what has not evolved so much really is how people interact with that data. So most of the machine learning and AI solutions out there require data scientists or computer scientists who have a high level understanding of how the data is formatted, how the machine learning models are networked, and how to put all these things together into solutions to arrive at useful products for companies. So they're actually pretty laborious. So if you think about how a self-driving system might work in that context, is you have to pull all this information together, and you have to have a data scientist that kind of massages the data and pipes it through a bespoke network to arrive at the solutions that you need for the car to stay on the road. Well, actually, what you want is a much more intuitive user interface for the user to be able to interact with the data without having to know all the detailed information that a computer scientist or a data scientist would want to know. So what we've really been focusing on is building that kind of interface. So we want to bring the power of AI and machine learning to general users. I mean, these are specialists in their own right. They're usually geologists, geophysicists, petrophysicists. So they're looking at subsurface data sets, but we don't want them to have to be specialists in machine learning and AI. We want them to be specialists in their domain, and then we want to give them tools to interact with the data and be able to build machine learning solutions for what they're interested in their workflows. And that's really where we've been working. But this is all made possible by the commoditization of the technologies behind that, which are the models, the networks, and things like ImageNet, the data, the big data behind it. And I mean, I see that continuing to evolve in the next few years. And where things are probably going to break out in a little more detail and actually provide a huge opportunity is data sets that will be much more industry specific. So, ImageNet is a whole general universe of different image data. Well, now you can think of the equivalent database for an industry. You could say, all right, if you've got a pipeline industry, well, maybe now you want images that are very specific to pipelines, to pipeline quality, to rusted pipes, to corrosion issues, to chemicals that are associated with that. And those will all be able to inform a specific subdomain within the overall AI and machine learning technological advance.
So let's dive a little bit deeper into that in terms of seismic. How revolutionary have advancements in machine learning and AI been, and where are we at today, and what does the future hold as well? What advancements are in the pipeline?
Yeah, so I mean, I would say so far as AI and machine learning in subsurface data, and it's specifically in, let's say, the seismic domain, we're really at the beginning of the journey. So we've taken the first steps and we've learned a lot. A lot of companies have built proof of concept products where there's a lot of work involved in getting to an answer, even though you're skipping a lot of the human interaction part. You have to condition the models right. Usually you have data scientists involved in the process. So you kind of go from a geoscientist who's building the labels, who's building the interpretation initially, and then that is kind of being fed to a data scientist who's sending it through the network architecture, the machine learning models that they've set up, and then getting out a product, and then that goes back to the geoscientist. So it's sort of several disconnected steps. That I would call the proof of concept stage. And that is really where we are today for the most part. Where we're going to go is the deployment stage where we productize these things. And for example, what we've built, subsurface AI seismic, actually combines all those steps. So the geoscientists can sit down and using tools that are very familiar to them from other interpretation packages, they can quickly build out a set of labels. Those labels will go through a series of machine learning models and produce a prediction. Now, the geoscientists will pull back that prediction and take a look and be able to edit and modify. And at each one of these steps, what they're doing fundamentally is they are teaching the machine learning models how to interpret the seismic data. And not only are they teaching it how to interpret the seismic data, but they're teaching the models to interpret seismic the way they want the seismic to be interpreted. So the more carefully you do that process, the better your results will be, and the more similar to the way you think those results will be. So that allows someone without a data science background to interact with not just the data, but with the machine learning AI world. And that's really where I see things going. So we've accomplished that for this first step with seismic data to build up horizons, faults, geobodies. I see that building out more and more. There's no reason it stops there. There's no reason we can't go to doing inversions, to doing all kinds of bespoke attributes and cross-plotting data. There are a lot of different opportunities in that space. And then companies will bring in more data types to integrate. And that's really where things are going to go in the, I would say, the medium to longer term, is where you integrate well data, you integrate all the rock data with the seismic data, and you kind of convolve a bigger network of everything. So if you perturb one thing, say you get a new well in, you pop that in and make some labels on that, and it can propagate across the whole data universe that you've set up. And so you get a much more holistic picture that can be regularly updated. And the other advantage of that is you gain a lot of efficiencies on time, and you gain a lot of efficiencies on consistency. So not only are you able to test things faster, but in theory, you should be able to test more models. So instead of one geologic model, maybe you can test 5 geologic models. And the consistency you can get out of your results improves markedly. So, if you take a portfolio approach to a whole series of fields or a whole series of exploration prospects, now you can look more robustly across all of them and compare apples to apples to see where your biggest value lies and where you should be focusing your capital as a company. So there are a lot of benefits that are going to come out of this. But realistically, a lot of these are going to take time, and they're going to take close collaboration between service providers who are building out these solutions and the product owners, the companies on the operating side that have skin in the game for the results.
Tell us a little bit about some of the projects that you're working on currently.
Yeah, so the projects we're working on currently run a range from sort of rapid scale proof of concept projects where we build things out very quickly to see whether there is a tractable solution. And the goal there really is to test whether you want to move further ahead with this. I can't speak of details on a lot of these, but they include things where we've tested how well we can integrate data sets of various scales really rapidly to be able to perturb part of a data set from changes in another part of a data set. So for example, you might have core data, including plugs, porosity information, maybe thin sections, and you might have well log data alongside that, and then maybe related seismic data. So how do you integrate all those things? Begin to actually use all the data, which we do not currently do in the industry, and how do you propagate changes in one data set across that data set to the larger scales of data, essentially. So, you might think of once you get a core described, now you know the actual rock properties that are represented in that seismic data set. And so you want to represent those rock properties in that seismic data set and perturb the seismic data. So the question is, how do you effectively do that very rapidly without having to do it fresh each time? And so we've done proof of concept level work on that. That will lead to a bigger project where we're trying to build out a product where you can do that very effectively and move in both directions with that type of data set. So there's one example. In the seismic space specifically, we have built out products that are related to, very closely related to work that we've done with a couple different companies on building AI machine learning solutions to seismic interpretation. And we've built those products specifically to solve the problems of the end user on the business units who very rapidly want to be able to analyze the seismic data, look at changes as they get more data in, and be able to use the results in not just their analysis, but in things like well planning and path design, things like that.
So can you elaborate a little bit about the challenges that you help some of these clients overcome?
Yeah, I mean, some of the challenges that we're working on overcoming with these approaches include improving efficiency in workflows, improving consistency in the results of the workflows, and improving quality in the results. Another interesting thing that is really coming out of this is by leveraging machines, we're able to analyze all the data in data sets. And that actually hasn't really been done before. So if you think about thin sections, and the way thin sections are used these days is that people put them under a microscope, they look at them, they'll scan the data, but they're looking at individual grains, they're looking at the porosity, and then they're point counting. And what point counting does is it goes across a grid and it checks these various points in a regular grid. And it's at those locations where the petrologist will describe the rock or the porosity or whatever's under the scope at that point. But if you think about that approach, it actually misses most of the volume, most of the area of the thin section. So you're not using all the data. With machine learning, we're able to use all that data there, then we can integrate it with all the data in the core and all the data in the plugs taken from the core, all the information that has gleaned from that, porosity, permeability, fluid saturations, et cetera, that can all be integrated and used. And then if you scale up to the petrophysical scale, there are a lot of runs, a lot of log data that's taken that's never used. Well, we can start to use all that data because the machines can handle all this data and then integrate it with seismic scale data sets. And you're able to integrate across all these scales, combine all the actual data, and you can arrive at better decisions because you've looked at things much more holistically. So those are some of the challenges that some of them are solved and some of them we're trying to solve. And they're a few years down the road, frankly. These are big challenges. But there's a big opportunity set here too, to be able to solve those and really make a huge leap forward in how we are addressing our energy problems and helping our energy partners make their capital allocation decisions, make them more robust while driving costs down through the efficiency side of the workflows that we're talking about.
So what advice would you give to operating companies that see the potential of AI, but might not know where to start?
Well, if an operator is interested in starting to work with AI and machine learning, the best thing they can do really is work with a partner. A partner that knows some of the landscape and knows how to help them find value quickly so that they can prove internally the value proposition that is promised by the AI revolution. It's there, it's real, but sometimes people go the wrong direction with it or they bite off more than they can chew with it. And it's not necessary, really. So sometimes small steps are best. And that's what we at Enthought call applied digital innovation. So, work with a partner, figure out a problem that can be solved, a tractable problem where you can improve efficiency, where you can improve quality, where you can find some value proposition, that will hit your bottom line within a reasonable time frame. That can be a proof point and a way to sort of take a stepwise approach toward a bigger digital transformation. It's an awful lot to bite off if you try and solve everything at once. And it's probably not a successful strategy. So it's much better to take some small steps, figure out the best problems to solve first, and go after those. And those aren't necessarily the biggest problems, because sometimes those are the most complicated to solve. But they can be small things that can add a lot of value.
So building on that a little bit, let's say you have a counterparty that is working with a company like Enthought and wants to harness the power of AI and machine learning. They've identified the right partner. Once the project begins, You've learned a lot from past projects. What pitfalls can be avoided? What advice do you have for folks in the early stages of a project, but also as the project evolves over time?
So when an operator is setting up a project to try to find value from a digital effort, let's say an AI machine learning oriented effort in this case, they need to be open to what possibilities might build the best value for them over a reasonable time frame. And a pretty useful way to approach that is by having an internal session with an external partner to dive into possibilities. So you sit down together and you start probing what are the problems, what are the bottlenecks in the company, how are workflows currently done versus reimagining what those workflows could look like given today's technology stack. So if you imagine a lot of workflows have been around for a really long time. They're not modernized. They weren't developed based on what we can do today. They were developed based by definition on what was available at the time. And most of those have not been brought up to current technology standards. So there's a lot of potential to make improvements on fairly simple and standardized things that can make a big difference for a company without searching too far afield. And so, my advice initially is spend a lot of time in the planning up front before you dive in, because otherwise you might be either biting off more than you can chew, tackling things that maybe don't add as much value, or overcomplicating what could start out simply become proof points for further efforts. And, ways for a company to learn how to carry out further efforts, because part of it is a way of learning as well. And some of it may require new governance structure in the company, because there are going to be different lines of reporting as you sort of build a digital transformation effort out further and further. So, be careful what you do, but and try to highlight things that are of most value initially.
Generally speaking, how do you determine which processes are worth streamlining or automating or optimizing using these advanced technologies?
Yeah, so I think when you're trying to figure out which processes would benefit most from an effort to streamline them or optimize them through AI machine learning, or really any other process, you really have to look at the value proposition. And the value proposition includes a few things. One is the monetary value proposition, which can be a combination of human time spent on a problem, spent on a process. It can include, time to collect data, how much the data needs to be massaged, or the steps involved in collecting the data. So for example, if you have to collect a core and then you have to collect plugs from the core and then you have to analyze those, well, there are a bunch of steps in there that right now, at least, certainly involve people. And it's not obvious how to automate those altogether. You have to involve people right now. So if it's not obvious or not easy to figure out how to automate something, well, then it's not clear that the value proposition is there yet. So that might be something to avoid. And instead, focus on things where there's some clarity, not just of the value that you could create out of it, but also how you might be able to go about that.
Where do you think the energy industry is at in terms of its digital maturity today?
I think the energy industry has very low digital maturity right now. We're at the beginning of a journey, I would say. A lot of progress has been made in the last couple years, and certainly the coronavirus pandemic has been a catalyst, but there are so many glaring spaces where we can improve. So if you think about, just for one example, collaboration. How do we do collaboration typically? Well, if you think about subsurface workflows, we have these rooms and people get together in a room and they look at a screen together and they chat back and forth, and that's useful. So how did that work during the pandemic when people aren't able to be in the same room? Well, I tell you, talking to people, it didn't work. So one of the things that we're building, and I think really needs to be built out in a lot of different software, are collaboration tools to spur the kind of organic collaboration that you have when you get together in rooms. So, a great example of that are Google Docs, if you ever use those. On Google Docs, you can, highlight something, you can send a comment and then put an at someone's name, send it to them, it'll shoot them an email, and they can click on it and they can see what you've been talking about in the doc. Why don't we have those for subsurface tools? Well, we're building those because we think those are actually an important step in collaborative workflows. We're also building tools where you can, share your work with your colleagues, get comments back and forth, send it to your manager and say, hey, look what I did here, or, does this look good? So I think that's a big space of improvement. I think there are so many spaces like that we have so much upside potential for digitalization, digital transformation, really, in the end, that there's a lot of potential for improvement. And we have a long way to go. We're really just beginning this. The question is how far along it will get, and what does the industry look like in 10 years? Because I think it'll be dramatically transformed.
Right. So what do you think can be done to accelerate that? I mean, why has the pace been relatively slow to date?
The pace has been relatively slow because companies are slow to adopt new technologies. They're hesitant. And a lot of that is understandable. People like their workflows, and they're going to be very reticent to adopt new workflows. The other thing that actually complicates the issue is the regulatory environment, right? So for example, if you're operating in the Gulf of Mexico, there are a bunch of boxes you have to check, and you have to be really careful, and there are good reasons for that, right? So any digital transformation has to take those things into account. You have to understand the regulatory requirements. So what do you have to be able to provide when you're developing a piece of software? So what does the expert need to be able to do to meet those requirements? And then what options are there to improve that? And in some cases, I think there's room to go to the regulators and say, look, here's a new process that maybe improves things, but really it'll take kind of an industry lobbying to change those sorts of things. And that takes time. So there needs to be a collaborative effort, but there's a lot of potential.
What are your thoughts about change management kind of across an organization?
Yeah, I think so. Change management is a very tricky proposition, right? Because you have so many stakeholders. And you really need to keep the user in mind, but you need to look at the bigger picture. So I think there are a few things there. One is that the companies that are building the products, which will cause the change, need to really pay attention to the user requirements when they're designing the product. Why make it difficult for someone to transition to your product? Make it easy, make it intuitive, pleasant. I go to the app store and download an app, and my child, when they were 3, could figure it out and intuitively be using that app, no problem. Why is scientific software difficult to use? Let's make it easy. And that will solve a lot of the change management problems, right? If you make something pleasant to use, people are going to want to use it. If it helps them in their job, people are going to want to use it. But then the bigger issue is kind of how you look at it from an organizational standpoint, because there are always organizational changes that come about when you improve workflows. Either you've created efficiency and maybe you don't need as many people doing that job. So the organization needs to think about how they can redeploy people to be effective in a different part of the company. And I think those are all part and parcel to the discussion when it comes to digital transformation, because it in the end, you are involving a lot of people and you have to have their buy-in to make an effective transition to a different technology, because they're the ones doing the work, right? The C-suite isn't going to do the work for them. They want the work done, but they have to make it accessible to the people who have to do the work day in and day out. And I think that's a really important part of it. But those can all be avoided by, all the issues around that can be avoided with good planning, good communication and messaging, and good product design that make the user want to use the product.
For operators, with so many companies touting the benefits of things like AI and machine learning, how can operators separate the wheat from the chaff and know that the counterparty they're getting involved with is legit?
Yeah, I think for operators who are trying to assess the landscape, they need to always be asking the question what they're trying to solve. What business question are they trying to solve? What process are they trying to improve, and why? And if those questions are always foremost, then they can answer it by looking at various technologies and seeing if those apply to help them improve whatever they're trying to solve. So, if you are trying to get to well decisions more rapidly, more efficiently, with better data sets, with more validation, then you might take a different approach than if you're trying to answer a different question. But those business questions need to be at the heart of whatever effort you're undertaking as an operator. Because if they're not, then you're just doing it for no reason that I can see, no business reason in that case. So there needs to be that value proposition behind it. If anyone is interested in learning more about Enthought or our products, the Energy Solutions Group, get in touch with me. I'm happy to talk. We can talk about solutions. We might not be the best partner, but we might be. And we're definitely willing to point you the right direction. But really, it starts with a conversation. So get in touch. Let's have a conversation, see what your needs are, and see how we can help you improve if we can.
Thank you.